Now, believe it or not, the molten puddle doesn't want to fall out. Unless you blow it out with the arc force, the molten metal wants to stay with the heat. It likes the heat. Hold the rod nearly straight up and down or angled slightly in the direction of travel, away from the weld. Try a circular motion and just make the puddle look the same as when you're welding flat. All the sparks will be coming your way, so wear protective clothing like a leather coat, some good gloves, and I like to cover my ear with a hat. Getting burned is a little distracting when you're trying to run a good weld bead. 6010 and 6011 won't give you a smooth finished weld bead, but they do provide deep penetration in weld joints and when making repairs. 6013 welding rods were developed for welding sheet metal on DC-. The rod is held perpendicular to the metal with a tight arc, and the travel speed is as fast as you can go without having the weld bead skip. Today, 6013 is more often used for general purpose welding with AC or DC+, and it is a good rod for the small, low amperage welding machines. One of the first things you'll notice about 6013 is that there's a heavier slag coating on the weld bead. The slag even covers the top edge of the weld puddle. This keeps the puddle more fluid, helping to produce a smoother, finished weld bead. Typically, 6013 is available in 332, 1/8, and 532. 1/8 is the most common size used, and try starting with an amperage setting around 130 amps on AC or 115 amps on DC. Because of the slag covering, the differences in the appearance of the weld are a little more subtle, but when the amperage is set too low for the situation, the puddle will follow the rod around, taking longer to tie in on the sides. The heavier slag may even interfere with the arc. If the amperage is set too high, the molten puddle and slag are extremely agitated and remain molten longer. When the amperage is about right, the weld puddle spreads out, tying in and moving easily with the motion of the rod. In the flat position, you can run straight or try a little side-to-side motion. Angle the rod somewhere between 45 and 90 degrees to build up weld bead. Scratch start the puddle, and maintain a short arc gap, even to the point of lightly resting the tip of the rod on the metal. Watch the puddle. The slag covers the top edge, but you can still get an idea of the weld buildup. Watch the sides to keep the weld bead straight, and just ease the puddle side to side. On vertical welds, 6013 was designed for a downhill application. You'll be welding away from the heat, so try turning the amperage up 5 to 10 amps. Angle the rod up so the force of the arc helps hold the puddle up. Maintain a short arc gap and try a slight side-to-side movement. Watch the outside edges to keep the weld bead straight and travel fast enough to stay ahead of the molten puddle. If you can't stay ahead of the molten puddle coming down, try moving a little faster or raising the amperage setting. For more weld buildup on heavier metal, 6013 can be run uphill. Start by turning the amperage down 5 to 10 amps. Try using a side-to-side motion, moving up fast enough to keep the puddle from dripping down. Make sure the sides are filling in to avoid leaving undercut. To make a horizontal weld, angle the rod up to help push the puddle up. Keep the rod nearly perpendicular to the metal or angled back into the weld just a little. Maintain a short arc gap and constant travel speed to produce a smooth weld bead. The molten slag will run down, covering the bottom, but watch the top side of the puddle. Move fast enough to avoid excessive weld buildup. Excessive weld buildup. While you're learning to weld horizontally, don't try to carry too much metal. Keep the weld bead small. If you need more weld, you can always run a second pass above the first one. Overhead with 6013, like every other type of welding rod, is awkward. Hold the rod straight up, or because of the mild arc force, you can angle it back into the weld a little bit and try a slight circular motion. The heat of the weld is going straight up, right where you want it. So if you can get in position to maintain a short arc gap and uniform travel speed, overhead will produce a good weld. 6013 is the favorite rod in many home shops. They're easy to light, they maintain the arc, and produce a good-looking finished weld bead. 7018 produces an extremely high-quality, good-looking weld bead. This is the rod to use for heavier fabrication and repair or any situation where there's stress on the weld joint. These rods rely on a heavy slag coating to protect the molten weld puddle from coming in contact with oxygen in the air. This heavy slag makes 7018 run a little different than the other rods we've looked at. With the fast freeze rods, 6010 and 6011, the molten metal in the weld puddle is completely visible. Slag covers the top edge of the molten puddle with 6013, but the filler metal and slag solidify pretty much at the same time. With 7018, the entire weld puddle is covered by molten slag. The filler metal actually solidifies underneath, while the slag stays molten on top. If you keep in mind that what you see is molten slag and understand what the metal is doing underneath, 7018 is fairly simple to use. And even though the metal is solidifying underneath, watching the molten slag behind the rod will give you an idea of the weld buildup. 7018 is a little more sensitive to arc gap and rod movement. Make sure you're comfortable so you can be as steady as possible. A scratch start will get the flux burning before you deposit any metal. If you're relighting a rod, there's usually slag covering the tip. You may have to bump the rod to break that slag, then scratch to get going. Once the rod is lit, start the puddle. Besides tying in and getting started wide enough, this gives a little extra time for the gases to cook out of the molten puddle. If you move too quick, gas pockets may cause voids in the weld bead called porosity. Most times they're not even visible until you grind into the weld bead. Porosity can also be caused by welding on metal that's rusted, painted, or has any contaminants on it like oil or grease. 7018 does require clean metal. After the puddle is started, try a little side-to-side motion, maintaining a constant short arc gap. In some situations, you can even lightly rest the rod on the metal. With a mild arc force and slag covering the puddle, you do want to avoid letting the rod burn up or pulling the rod away from the metal. You don't want to let that slag cool, so keep the arc in the puddle. The typical rod sizes are 332, 1/8, and 532. Because the flux contains iron powder, which deposits more metal in the weld puddle, 7018 requires a little higher amperage, and these settings may vary up or down depending on metal thickness, weld position, and your ability to control the movement of the rod. With molten slag covering the entire puddle, you depend more on how the puddle acts than how the puddle looks. If the amperage is set too low for the conditions, the puddle won't spread out, taking longer to tie in on the sides. The rod might stick or go out. If the amperage is set too high, the puddle is agitated and extremely fluid. Little balls of metal might dance off to the sides, causing excessive weld spatter. When the amperage is about right, the slag solidifies back from the rod. The sides tie in, and you can ease the puddle side to side.